All right, so parent functions. So what's the point of a parent function? So like I said, I'll give you a little intro here. We're ready? You ready? Okay. So every function type has a parent, right? So that parent, if you know it well, can help you graph the more complicated versions of it. For instance, the parent function f of x equals x squared, right? If you know that really well, then when you get more complicated, like if you have f of x equals 2 times x minus 3 squared plus 4, you don't have to start from scratch and be like, well, I guess I'll make an xy table and keep plugging in some x's and finding y's. No, you know that one. You know what the 2 does, you know what the minus 3 does, you know what the 4 does, or you will, and you can just move around your parent function, okay? So if we know this, we'll know this, right? So we're gonna start with this, these parent functions. So what is a parent function? Parent functions, so when we talk about functions in general, I feel like a lot of students, it's like we talk about functions, and then we talk about linear functions, right back to back. So then we think, oh, functions are linear. That's just one function, one type of function. On your tests, a lot of people say, oh, it's not a function because it's not a line. Well, that's not true. It doesn't have to be a line to be a function. A linear function is one type of function, right? There are many types of functions, and we're going to talk about a bunch of different types today. And the parent function is the most basic, simple version of a function, right? So we'll start with that definition, right? We'll be writing all over this homework that you did. So a parent function is the simplest form of a function type, right? So you have your different types, and then the parent is the simplest version of that, right? And I'll show you why with each example, okay? So, parent functions. So each of these functions have different characteristics, and each of them has a different domain and range. So we need to be solid on what domain and range is before we can talk about them. So let's just review that real quick. Remember domain. We talked about that in our last unit. What is domain? Domain is all our what? X values, our possible x values, right? The values that if we put them in, we get a y, right? So there are possible x values. And then our range, we really didn't talk about as much, except for a little bit when we talked about functions, but now we're going to be talking about it a lot. If our domain is our possible x values, what do you think our range is?
Y values.
It's our possible y values. So the x values are the values that if we put them into the function, we get a y. The y values are the y values that would come out if we put in our possible x values. All right, so that's the context we got to look at all these through, okay? Which brings us to our first function, right? This f of x equals x, right? So with any function, remember, f of x is just a fancy way of saying what?
Y.
Y, right? So if it makes you comfortable, every single time you could rewrite it as, like you just don't really love that f of x, right? Rewrite it as y equals, and then what the function is. In this case, it's x. Y equals x, okay? Now y equals x, think about what that's saying. Y equals x. Y is x, right? They are the same. If you know one, you know the other, right? Pretty simple. So that means if x is -2, then, and by the way, this is y, right? If x is -2, then f of x is -2, right? It has to be the same, right? -1, -1, 0, 0, 1, 1, 2, 2, right? X is y, y is x, they're the same, right? So what does that look like? -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. Oh, we got a line, right? This is our first type of function. Okay? This is what's called a linear function. So it's a line. Okay? Now, I told you that these are the simplest form of a situation, right? Simplest form of a type. The type is linear function. That's as simple as it gets. And here's why. What do we usually talk about? How do we usually write our lines? What's the most common way? Y equals mx plus b, slope intercept, right? Y equals mx plus b. Well, let's break down our m and our b for this one. Y equals, well, what's in front of the x? 1x. And then what do I add to it? 0, right? So my m is 1 and my b is 0, right in the middle of the graph. You can't get simpler than that. That's why it's the simplest form of a line. And if we wanted to change this line, we wanted to move it up, we wanted to make it go higher, we wanted to make it go down, instead of, we would just change these other values, right? But we start with y equals x. That's the most basic one, right? That's our parent, right? And then we go from there. This is also a special line, the y equals x line. You notice it cuts the graph exactly at a diagonal, right? There are certain types of functions that reflect over this line. We'll talk about that at different points in this class. But it's a parent function. For today, that's what you need to know, okay? Now, domain and range. Remember we said it's our possible x values and possible y values. So, where a lot of students, like for instance, in my last class, I said, oh, what's our domain? What are our possible x values? And somebody said, oh, -2, -1, 0, 1, and 2, right? They're looking at the table. The table is a tool we use to graph. It's a snapshot of the function. It's not the whole function. It's just something that helps us get points. That's the whole function, right? And when we think about the possible x values, right? Well, my x is here, -1, -2, -3, -4, -5, -6. Would it keep going?
Yes.
Yeah, I got a little arrow here. It says it keeps going, right? Where would it stop? Never. Where would it stop going this way?
Never.
Never, right? So that's what we think about when we think about the domain, right? So how do we say that? Forever in both directions.
Negative infinity.
There's a couple ways, right? We could say negative infinity to positive infinity. Or we could just say all real numbers. And that is not a hashtag, that means number. Or a pound symbol on a phone. All right, so that's our domain, all real numbers. Our range then, or our possible y values, right? So it goes, again, it goes down to -6, it goes up to 6, but we know it keeps going. So what is our range? What do you think? All real numbers again, right? There's no limit that way, there's no limit that way. So all real numbers, and there's multiple ways to write this. I find that students love to just say all real numbers, done, right? And that's fine. Okay, that's a linear function. That's the one we're kind of familiar with, right? And in fact, there's a special linear function that gets its own category. And that's our next one, okay? Our next one, again, if it helps, we can always say f of x, kind of weird, I'm going to rewrite it as y. Right? Y equals 1. Because this kind of tells the story a little bit, right? This tells me that no matter what is y? 1, right? Y equals 1. Bottom line. Doesn't matter what x is, right? So what about when x is -2? What is y? 1. Negative 1, what is y? 1, it's 1. It just says it's 1, that's all it tells us, right? And this is our y, right? So now we have some points, so we can throw them on the graph. And again, we see a line, but it's a special type of line because it goes straight across, right? And this is called the constant function. And by the way, y equals 1 is just an example. You could have y equals 5, you could have y equals negative 5, you could have negative 100, whatever. It's just y equals a number, right? And again, we're trying to say, hey, this is as simple as it gets, right? So let's think y equals mx plus b again. Let's start with our b. Where does that thing cross the y-axis? Where is the y-intercept?
1.
1. So we know it's plus 1. And what's its rise over run? How much does it go up?
0.
It doesn't, right? So its slope must be 0. So I have 0x plus 1. So now I have an m of 0 and a b of 1. So it's just like this first example, but we've kind of flipped the simplicity, right? That one was simple in one way, this was simple in another way, right? Okay? So let's talk domain and range. My domain are all my possible x values. What's the limit going that way?
Infinite.
There is none. What's the limit going that way? How do we say that?
All
All limits. Now for my range, it's my possible y values. What are my possible y values here?
1.
There's only one and it's 1, right? So there's a couple ways you could write that. These hard brackets say, hey, include only this. Or you could just say y equals 1. That's my range. Y is 1, no matter what. Right? That tells the story. Okay? Those two we're a little familiar with. We've been dealing with them for a little bit. Now we're going to move on. Now notice in my linear function, right? Let's take a step back. What is my x being raised to? To the 1. That's what makes it linear, okay? Even if it was like x plus 2 divided by 5 or something like that. If the x in there is being raised to the 1, it's linear. The only exception is if x is under the fraction. But x to the 1, 99 times 1100, you got linear. What changes here is now x is being raised to the second power. And when you have x raised to the second power, that's a quadratic function. Okay? So even if you have a lot of other stuff going on, if the highest degree you see, the highest power is to the second, you have a quadratic function, okay? So what happens? Well, there's an important thing that we need to make clear here. Well, first of all, we can think of this as y equals x squared, and then remember that this is our y. And then we plug in our x's. Now I'm going to tell you what this is not, because a lot of students put this and then don't get the right answer. This first one would be f of negative 3, and it is not negative 3 squared. You might be like, well, hold on, it says x squared, that's my x, I plugged it in, what's wrong with it? Why is it not negative 3 squared? Anybody know?
Negative 3 is a number by itself, so you should put brackets around the negatives there.
Yeah, so what negative 3 squared actually is, what you're actually writing when you write that, is negative 1 times 3 squared. which is not -3 squared, it's -1 and then 3 squared, which would give you 3 squared is 9 times -1 is -9, right? That's not what we want. We want -3 squared. So what we want to write is y equals -3 squared with the parentheses, because that makes it so we do square the number that's being given as our x, right? Now we get -3 times -3, which is a +9. You see how you would have got a -9 there, right? But that's not what's happening here. We're actually squaring the number, multiplying it by itself, -3 times -3, which should give you a +9. So if you put in your calculator like that, it'll give you a -9 and you'll get the wrong answer, okay? Make sure you have those parentheses. Then we just do that for every single one of these, right? -2 times -2 is a +4. -1 times -1 is a 1, 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, okay? So this goes on our graph now, right? -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. It makes kind of a what? A U, right? Which, yes, is called a parabola. Now, important distinction, this is not a V. It is a U, it's a curve, right? And yes, the shape, you want to know the name, it's called a parabola. And there's a lot going on here, right? What unique characteristic does this shape have? Anybody know?
It's a curve.
It's curved, right? There's a lot of curved functions. This one's got something
It has a
special.
turning point.
Turning point, yep. So do a lot of functions. What's uniquely unique about a parabola and maybe like one other function? Yeah.
There are points in the same section.
Yeah. What do we call that?
Here.
It's mirrored, but there's a fancy way to say it. Just with an S. Same on both sides. Symmetrical. A parabola is symmetrical. It means the same on both sides. Both sides of what? Of a line that goes down the middle. Called the line of symmetry. Right? And we're going to get into all of this, right? We'll have full lessons on this, but giving you the big picture here. Why is that useful? Well, if you're trying to graph a parabola, you know, and you find this point, and this point, you don't need to do the work to find that point, and that point. You just flip them over the line, and you have 3 more points, right? So if you know that it's symmetrical, it really helps you graph it. Yeah, question?
Is it always going to be like that if it's x squared?
Mm-hmm. All x squareds are symmetrical. Yeah, very good question. All right, so line of symmetry, think of a line of symmetry this way. If this was a piece of paper that you folded, it would fall on top of it, right? This would fall on top of that would fall on top of itself, right? That's what symmetry is. It's a mirror. If this was looking in a mirror, it would see that, okay? All right, what else? Oh, domain and range. So domain and range. Okay, so if domain is all our possible x values, we have to think about what our limits are, if we have any. Now, it looks like this thing's going up and up, right? So, do you think that there's a limit as we go that way? Why not? I agree.
Because it's not going straight up.
It's not going straight up, it's going up to the side. It's going up to the side. And yeah, it's going pretty slowly to the side, but it has infinity to get where it wants to go. So eventually it's gonna get to infinity, and eventually it's gonna get to infinity, right? So it does go to infinity, just not as straight as a line does, right? So domain is all real numbers, good. But now we have a different situation because our range doesn't go forever down, doesn't go forever up. So we got to start thinking about when we have limited ranges or domains, we kind of scan. For domain, you would kind of scan left to right. For range, you would scan bottom to top. And you would go from the bottom and you go and you say, where's my first y value? Right here, right? So that's kind of my border wall. That's where it begins. And then does it have any limit going that way?
No.
So if I had to describe the possible y values, I would say anywhere from
0.
to
Infinity.
infinity, right? So that's my range. And I can say it a couple different ways. So say 0, comma, infinity, or y is greater than or equal to 0. It can be greater than 0, it can be equal to 0, and that tells you the story, right? That's your range. Okay?
Is it meant to have the fancy bracket and then
Absolutely, good question. So 0 has a hard bracket because that's something you could plug into the function and get a value for. That's an input that's included. Infinity is not something you could plug into a function and get a value for. So it gets that soft bracket. Okay?
I remember.
Must have had a good algebra one teacher. Yeah, so that's why those brackets are different. Okay, so that's a quadratic function. Okay? Ready to move on? Next up, we have a funny looking square root function. So this is the square root function. And remember, you could always think of it as y equals. Y equals the square root of x, where this is my y. So we start to try to plug these in. And I start with this one. Well, this would equal the square root of -1. Let's pause and talk about square roots. Okay, so somebody explain to me what the square root of 4 is and how you know it is.
2.
It's 2, but how do you know that? Like, if you had to prove it, what would you say?
The square root is the smallest number that could go into a number an even amount of times.
Go into in what way? Go ahead. What were you gonna say?
Like 4 is 2 exponent 2, and when there is an exponent, it removes the radical.
So yeah, so
An even exponent.
yeah, so even exponent, square root it, it's whatever it is. Anybody want to add?
I'm not sure if it's right, but is it whatever times itself is?
Yep. So square root, in most basic form, is whatever times itself would give you the number under the radical, right? So we know it's 2 because we know if we multiplied 2 times 2, we would get 4. That's why the square root of 4 is 2, okay? So now let's talk about the square root of -4, right? What are we trying to find? We're trying to find a number that if you multiplied it by itself, you would get -4.
Impossible because it's negative times a negative.
It's not possible. Think about what our options are. Well, 2 times 2. Well, that's positive 4. But let's try -2 times -2. That's also positive 4, right? It turns out this can't be done. You can't times something by itself and get a negative. So, what have we learned about square roots? You can't, what?
No, I was gonna say you put the negative outside.
That's coming in the future. You're ahead of us. You can't square root negative and get a real answer. There are things called imaginary answers. We're going to get there. But you can't square root a negative for a real answer. Okay, so I bet you some of you doing your homework put square root of -1 in your calculator, and what happened? Error. That's your calculator telling you, nope, I can't do it, right? So when that happens, we say undefined. And think about what that means. That means that that input, -1, what's the output?
Undefined.
There is none.
There is.
So there's no x-y combination that makes this thing true. So there's no point at -1.
Ah.
There is no y. Therefore, there is no point. These are only values that make the function true. If you can't make it true, there's no point there, okay? Now the square root of 0, 0. Square root of 2, you would have to put into your calculator and it would give you 1.41. Yeah, it wouldn't be a whole number. It would be about 1.4, but out very far, right? But we'll estimate so we can get a point in the graph. Square root of 4 is 2, square root of 9 is 3. So that looks like this, 0, 0, 1.4, 4, 2, 9, 3. And it would go from there,
Oh.
okay? Yeah.
So I don't think I was supposed to do this, but I added a second side.
Down here?
Yeah.
No, because what you're thinking is, oh, square root of 4 could also be -2. Is that what you're thinking?
Yeah.
That's only true when we're solving equations, when we're trying to find all possible solutions. If you're just talking about square root in and of itself, on its own, it's the positive.
Okay.
But when we start, it's going to be confusing when we start doing equations. I'm going to say, hey, you need to do plus or minus, because that's when you're trying to find possible solutions. And that's not what we're doing here.
Okay.
Okay? So it doesn't go down. It also wouldn't be a function, right? You can't have two outputs for one input, so that wouldn't work. All right, so let's talk domain and range. Okay, so again, you want to scan this thing for domain and range. Go along the axis. I'm going along the x-axis until I see something. Where do I see it? Boom, right here, and I build a wall. And then, do I see any limit over here? No, so it goes to infinity. Coming from the bottom, I'm going to scan on the y until I see a point. Where do I see it? At 0. Is there any limit going this way? Nope. Goes forever. So, if I had to describe this to say someone, I would say, well, that means x can be anywhere from 0 to infinity, or x is greater than or equal to 0, right? We could also write it as 0, infinity. Coming from the bottom, if I had to describe the y to somebody, I'd say, well, y can be anywhere from
0 to infinity.
0 to infinity. So y is greater than or equal to 0. All right, moving along. Absolute value. Okay, so absolute value, by definition, means the distance from 0 on the number line. That's like the formula. So like -3 is 3 spots from 0 on the number line, so the absolute value of -3 is 3. The absolute value of -6 is 6. The absolute value of 4 is 4. 8 is 8. But in layman terms, what do you do? Just make it positive, right? So you're just making it positive. Okay? Remember, we could always rewrite it. Y equals absolute value of x, and this is our y. So the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. 1 is 1. 2 is 2. Just make it positive. If it's positive already, leave it as positive. All right. On our graph, we got -2, 2. We got -1, 1. 0, 0, 1, 1, 2, 2. And what we end up with here is kind of a V situation. In fact, it is a perfectly symmetrical V. Which is also why we don't want to make our parabolas look like V's, because then they might look like an absolute value function. Okay? And then here's some higher level stuff here for you if you're interested. Remember the first one, y equals x? Cut the thing completely. Well, this is the same thing, except all the negative values got absolute valued, and flipped up to positive, right? So if you flip this line down, you'd have the y equals x line,
Right.
right? And that's why that's why it behaves the way it does. Okay? Question?
So it's called the absolute value function?
Yeah, sorry. Absolute value function. Okay. Domain and range. Also, by the way, if you want to write down, this is also symmetrical. I'm going to skip that in the interest of time. Okay, x values. Start at the left, I see an arrow. I go to the right, I see an arrow. That means all real numbers. For y, I start at the bottom. I don't see an arrow. There's no value yet. So I'm going to go up until I see one. Where's my first value? 0. So I have a wall here. And then, is there any limit going that way? No. So if I had to tell somebody, hey, the y's here can be anywhere from 0 to infinity. In other words, y is greater than or equal to 0. It can be 0 or it can be more than 0. And that tells the full story. Okay? One more. Okay, so the last one, remember we said x to the 1 is always going to be what? What type of function? Linear, right? 99% of the time. X squared is always going to be quadratic. And then we have this one. X to the third. Now to the third power. So this one we call cubic. By the way, we call it cubic because if you have a cube, there are 3 dimensions. There's length, width, and depth. That's 3 dimensions. You'd have to multiply all 3. It's cubic. All right, so remember we can always rewrite this as y equals x to the third, and this is our y. Okay? Now, what happens here is a little different than a quadratic, because what we get, remembering that we always put it in parentheses, if I have negative 2 to the third, well, that's not telling me twice, that's telling me 3 times, so that's negative 2, negative 2, negative 2, which, left to right, negative 2 times negative 2 is 4, times negative 2 is negative 8. So, negative values are possible here for y. Negative 1 times negative 1 times negative 1 is? Negative 1, right? Negative 1 times 1 is positive, and then it flips back to negative. 0 times 0 times 0 is 0. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And we end up with this. Now these can be a little difficult to draw because of the concavity switch. And concavity is a tricky thing to understand. It's basically like, is a cup up or down, right? So what I suggest is do the first one kind of like the side of a parabola, and then the other one kind of like a flip down parabola. And then you'll get that concavity switch that you want at the meeting point in the middle, right? This one can concave down, that's concave up. You don't need to know that word yet, but if you want to graph it so it looks correctly, that's what you would want to do, okay? All right, last piece, and then we're done. Domain and range. Okay, so my domain here, remember, if it looks like it's going up, and it's not going straight up, it's going up and out, well, that's enough, because even if it goes really slowly, it goes to infinity, right? Because it eventually will get there. So my domain is all real numbers. And then finally, our range, well, if I look at the bottom, there's an arrow. I look at the top, there's an arrow. All real numbers. and we have our parent function.